Hello student, I am Arnab Das. Today we discuss about the Hamming bound and Golay codes. For Hamming bound, if an n comma of k, where n is defined the code word length and k is the message bit, if an n comma of k LBC is capable of correcting t bit errors, then it is necessary to have the number of syndromes to be at least equal to the total number of correctable error pattern. That is, it should follow this one form. That is, the 2 to the power of n minus of k should greater than equal to of summation of I is equal to 0 to t for the combination of c for ni. The above inequality is called the Hamming bound. That means if this kind of inequality follow any kind of code, that time this inequality will be defined as a Hamming bound on there. A code for which the Hamming bound turns out to be an equality is called the perfect code. That means which one is follow this one form, that kind of code will be defined the perfect code. It is to be noted that all Hamming codes are the perfect code. That means each and every one Hamming code, whatever you have to think, that one should be a perfect code. For example, consider the 7,4 Hamming code. Hamming code are the linear code also, that is LBC. So it can be written down as a form of n comma of k, where n is the code word length. So in this case, 7 is the code word length, that is n is equal to 7, and 4 is defined the message bit. So this is k is equal to 4 on there. So for this case, the example consider a 7,4 Hamming code. So there n is equal to 7, k is equal to 4, and t is equal to 1. If it is, then 2 to the power of n minus of k, this will be equal to 2 to the power of 7 minus of 4, which is equal to 8 on there. So you can got this one value. So this one we are interested to identify the inequality in a Hamming bound. So initially at first you have to calculate 2 to the power of n minus of k on there. Now for the summation of this combination, and which is varying from I is equal to 0 to up to t, due to the reason of t is equal to 1, so it's, if it is starting from the 0, so it will be 0 and 1 will be as a varying form. And for this reason it is written on here t is equal to 0 and 1 up to t is there given for the question, t is equal to 1 on there. So it is starting from the 0 to up to 1, then the combination will be as a form of c is equal to combination c 0 to 7 plus c 1 7 on there. So individual one, the value will become for the first one as a 1, and for the second one it will be 7. For recapitulate, we just write down here the combination formula. What is this is given as c of nk is defined as n factorial by of k factorial n minus of k factorial. So you can remember this one, and then automatically you got the value for individual combination one on there. So ultimate, in this case, summation of 0 to t n combination of c n I, this value will become as a form of 8. So in here this one is 8 and this one also the value of 8. So it's follow this one inequality. So this is a Hamming bound, or due to this reason it is fulfill the Hamming bound. It's also treat as a perfect code. Thus 7,4 Hamming code is a perfect code. Similarly, it can be shows that 15, 11, 31, 26, 63, 57 Hamming codes are also the perfect code. The same way you can prove that is it 15, 11 where the 15 is defined the code word length, 11 is the message bit. So in this case, is it is a Hamming, obviously the Hamming code is a perfect code or not, the way already I told. Now we are talking about the Golay code. For the Golay code, in 1949, Golay discovered a possibility of combination 23, of 12. That is the message bit is there 12 and the code word length will be 23. So this kind of combination construct the perfect code. That particular code is defined as a Golay code. Binary Golay code are one of the very important classes of linear block codes since they are one among the very few set of non-trivial perfect code. So this is the important one because if there bunch of error is occur, that time it can able to identify for any kind of bunch formation. If there any error is occur, then it can be identified. But it should be remembered that how many number of bit greater than the value of 1, how many number of bit position if the error is occur and it can correct, it is also defined on there. They satisfy the Hamming bound condition for the perfect code. That is it. If you prove the by the previous way, you can able to see that this follow the inequality form, and that means this is also a perfect code. We are just going through the parameters for the Golay code. Parameters for a Golay code are number one, n is there 23, that is the code word length, and k is equal to 12, that is the bit, data bit or the message bit is the 23. Number of parity bit will be should be in minus of k then, so this value will be 23 minus of 12, that is equal to 11. So 11 number of parity bit you should be required to identify and also to detect the error if it is occur at the receiver side after it is getting the code word. It can identify is there any error is occur or not. If it is occur, then where and how it is changed, it also can identify on there. The number of error correcting capabilities t equal to 3. That means the bunch of error of 3, that is 3 bit position if at a time any error is occur. If we talk about the Hamming code, then only the single bit position if any error is occur, that time it can correct. That is single bit error can correct on there for the Hamming code. But in this case, it is capable of correct up to the 3 bit position of error. So this is an important point also for the Golay code. Now for the generator polynomial. Generator polynomial may be as a form of gx is equal to 1 plus x square plus of x4 plus of x to the power of 5 plus of x to the power 6 plus of x to the power 10 plus of x to the power of 11. Or maybe this is the generator polynomial as a form of 1 plus x plus of x to the power 5 plus of x to the power 6 plus of x to the power 7 plus of x to the power 9 plus of x to the power of 11, and here d min is equal to 7. So 7 bit position, if the error is occurred, then it can be identified 7 minus of 1, that means 6 bit position if there any error is occurred, then it can able to identify yes there an error is occurred, and it can correct up to 3 bit position, 3 bit error if it is occurred, then only the 3 bit maximum is occurred, then it can correct the 3 bit position error also. So if you know the value of the generated polynomial for the LBC, you can able to identify the code also, because we know that the uh, C there the code C is equal to D and this is G. So in here this is G is given to you, G is given to you. From here you can generate the G. So G is given to you and T is their number of bit formation. How many? This is K is equal to 12. So D their number of 12 tuple number of formation can be created on there for the P. So from here if you uh, multiply this matrix form, then you can got it the code word also on there. So this way the Golay code can be generated, and Golay code already I told that this is the specified one by the Golay in 1914, and so you cannot be changed to any kind of alternation. This is obviously predefined on there, and here the generator polynomial should have to take this one or this one. So I think each and everyone can able to understand what about the Hamming bound and also the Golay code. For any query, please call. Else, I have to say bye and have a good day.